Let's talk about power of a study, type 1 error, type 2 error, effect size. So, what is power of a study? Let's say we have one drug, newly discovered drug called drug X for systemic hypertension, and we want to test whether this drug X lowers blood pressure, systolic blood pressure more compared to losartan, right? So let's say if it actually lowers, in real life, and your study is able to detect it, that is true positivity, right? That is the power of the study. So in fact it lowers and your study is able to pick up that is the power, right? Let's say that actually does not lower the blood pressure, right? That does not lower the blood pressure by a certain amount. Let's say effect size is 10 mmHg. So what is effect size? The difference in blood pressure between the two arms, systolic blood pressure between drug X and losartan. So let's say actually it does not lower blood pressure by 10 mmHg, but your study finds that it lowers blood pressure by more than systolic pressure more than 10 mmHg. So what is it here? It is false positive. Your study concluded that it lowers the blood pressure, but in fact it does not lower. So that is the type 1 error, or we call alpha. It is concluding false positive result, right? And what is beta or type 2 error? That is false negative. So let me put it another way. So what is false negative? So in fact it lowers blood pressure by more than 10 mmHg. In fact it lowers the blood systolic pressure by more than 10 mmHg, but your study is not able to detect it. Your study concluded that it does not lower the blood pressure by more than 10 mmHg. So you have concluded false negative result, right? So that false negative result we call it type 2 error or beta. And the definition of effect size, I already told you, the difference in systolic pressure between the two arms is the effect size. So here we have kept effect size as 10 mmHg, but effect size we can also keep at 20 mmHg, 30 mmHg, or even 5 mmHg. So as effect size is more, what does it signify? It signifies that this drug X lowers blood pressure more than losartan, which is our comparison, right? So if you think in other way, like let's say you are catching a fish with a net, right? So if your net is bigger, right, there is more chance of catching fish, right? If your net is bigger and you throw in the pond or ocean, there is more chance that you will catch the fish. The fish is true positive. The difference, the effect size. So that is the power of the net, right? So power of the study is the ability of the study to catch the true positive, to catch the fish, right? That is the power. But when you throw a net in the ocean, it will not only catch fish, it also catch some waste material, some plastic, some can that people have thrown in the ocean, some shoes, some slippers, whatever maybe. So it is not only catching fish, but also some waste materials, right? Some octopus, some tortoise, some turtles, right? So those are false positive. Those turtles, tortoise, waste materials, cans, plastics, shoe, slippers, those are false positive, right? So in addition to catching the fish that is true positive, it is also catching false positive, that is those non-fish materials, non-fish, let's say, right? So as much you make your net bigger, when your net is more bigger, what happens that it will catch more fish, but it will also catch more non-fish materials, right? So similarly, when you increase the power of the study, like you have kept power 80%, right? And when you make the power 95%, so in addition to detecting the true positive, true difference, it also will increase the type 1 error rate, that is false positive rate. So if you increase the power of the study from 80% to 95%, it will increase the alpha or type 1 error rate. Like let's say it was 5%, it will go to 15%. This is just a hypothetical example. So the alpha or type 1 error will also increase. I mean the false positive is also increased if the power is increased. So both is going in the same direction. So if power increase, if you increase the power of the study, the false positive rate, the alpha or the type 1 error rate is also increasing in the same direction. I hope you got this analogy. And now let's talk about relation between effect size and power of the study. So as I told you already, what is power? So let me reiterate. Power of the study is ability to detect the difference in the effect size, that is the 10 mmHg pressure difference between the two arms. That is the power of the study, the ability of the study, right? And effect size is 10 mmHg. So if you make effect size 20 mmHg, what will happen? Or 30 mmHg. So if you increase the effect size, the power of the study will also increase. Let me put you again in the example of the net and fish. So if the effect size, let's say effect size means the size of fish. So if the size of fish is more, the net will catch it more, right? The net has the ability to catch it more. If the net is bigger and fish is also bigger, so the small fish can escape it from the small holes of the net, right? But if the fish is bigger, there is chance of the fish to get catched in the net. This is just an analogy, for example. So you can think this example from another way as also, but don't think that way. I just think in this way because this is just an example analogy to make you more clear, right? So as you increase effect size, the size of fish, the power is increases. The ability of the net to catch fish increases if the size of fish increases. So if difference in the blood pressure between the two arms increases from 10 mmHg to 20 mmHg, power of the study also increases from 80% to 85% or 90%. Basically, power means the ability to detect the difference, the true positivity between the two arms, right? And if the effect size is more, then there is more chance of getting detected. So in a crowd, you may miss the small things, but if some things are bigger in size, you can easily notice it. So effect size is bigger, then there is more chance of getting it detected. So power of the study automatically increases. So I will continue this video later.